Hello dear learners, this is Dr. Sedhupathy, Assistant Professor of Computer Science with Artificial Intelligence and Data Science, Dr. SNS College of Arts and Science, Coimbatore. So today we are going to discuss about methods for handling deadlocks. So agenda for the discussion will be like methods for handling deadlocks, deadlock prevention, deadlock avoidance, and what are the safe states for the deadlock prevention or avoidance, and basic facts about deadlock prevention and avoidance, and the different states like safe state, unsafe, and deadlock state, and avoidance algorithms which are used basically in the deadlock handling. And these are all the methods for handling deadlock. But basically, a system should ensure that it will never enter into a deadlock state, which can be occur based on two deadlock techniques called deadlock prevention and avoidance. Deadlock prevention is like once deadlock or the machine enters into deadlock, how you can overcome from that is called deadlock prevention. And deadlock avoidance is before entering into deadlock state, you're supposed to detect is there any possibilities of avoidance of deadlock, which allows the system to enter into deadlock state and the recovery, and ignore the problem and pretend the deadlock never occur in the system. And so these are all the four deadlock prevention policies. Basically, mutual exclusion, which means not required for shareable resources. So example, you can use read-only files. So which means that if there is non-shareable resource, there is a possibility of deadlock occurrence. So you're supposed to use shareable resource to avoid deadlock. And there is a hold and wait mechanism, which must be guaranteed that whenever a thread requests a resource, it does not hold any other resources, which is a thread or task request a resource, that the thread or task should complete the resource utilized by itself before and release the resource, then only it can able to request for the other resources. So which is that the required threads to request and be allocated all its resources before it begins execution, or allow thread to request resources only when the thread has none allocated to it. So low resource utilization, which means that it is a starvation policy for the deadlock prevention. And coming to no preemption mechanism. If a process that is holding some resources requests another resource that can be immediately allocated to it, then all resources currently being held are released. So basically, preemption is nothing but there should be a high priority whenever a resource request comes, that resource should be released by other processes which are currently using it. So that kind of policy is preemption. If there is a preemption, the resources can be released immediately whenever the request arises. If there is no preemption, the resources will never release it until it completes its task. It will be restarted only when it can regain its old resource as well as the new ones that is requesting. And coming to circular wait in the deadlock prevention, it actually insists or impose a total ordering of all resource types, which means that require each thread request resource in an increasing order of enumeration. So invalidating the circular wait condition is most common. Basically, simply it assign the each resource into a mutual lock, which means a unique number. So the resources must be acquired or given based on the already defined or already assigned order. And coming to deadlock avoidance. So basically, before getting enter into deadlock state, if possible, you can able to avoid deadlocks, which requires that the system has some additional priori information available. Simple and most useful model requires that each thread declare the maximum number of resources of each type it may be need. So the deadlock avoidance algorithm dynamically examines the resource allocation state to ensure that there can never be a circular weight condition. So the resource allocation state is defined by the number of available and allocated resources and the maximum demands of the processes based on the request and deadlock avoidance content can able to achieve. And coming to some basic facts about resource allocation and deadlock prevention and avoidance. If a system is in safe state, there is no deadlock. And coming to suppose there may be a possibility of system getting enter into unsafe state, which means that there is a high possibility of occurrence of a deadlock. So before that, you can sometimes avoid deadlock occurrence. You're supposed to ensure the system will never enter into unsafe state. And here is some simple diagrammatic representation of 3 different states of deadlock: safe, unsafe, and a deadlock state. Actually, a system is in safe state, then there is no discussion. If you come to unsafe, inside unsafe, the deadlock state is a subset, which means deadlock state is some subset of unsafe state of the system processes. So there are few and most familiar deadlock avoidance algorithm. If resources are using single instances, then there is use of resource allocation graph can avoid the deadlock. If resources are having multiple instances, the familiar algorithm for avoiding deadlock is Banker's algorithm. So thank you for your patient listening, dear learners. So I will like to share the deadlock avoidance algorithms in the upcoming videos. Thank you once again.